Well, welcome to the Innovation Lab. So here we're sitting inside the Hatfield Marine Science Center in the new Marine Studies building, and within the space that we're calling the Innovation Lab. We aid the researchers here, the students as part of the Oregon State University, and the community members broadly located out here in Newport. This lab enables the design and development of unique instrumentation to allow us to study the ocean. If we want to measure temperature or pressure in any of these unique environments, we need to create our own way to do that. So a lot of time that involves developing our own unique system. For most of the problems that we're trying to solve, there isn't some clean off-the-shelf solution that we can just go buy and drop into the water. So for some of the problems, we have to add on to, say, a drone. So here's a drone that researchers are using to investigate whales. What we've done is we've modified this drone by adding on a sensor that allows the researchers to better use this drone. So let's take a better look at what is involved in making one of these. The 3D printer is a unique tool that we used in making part of this instrument. It's what actually builds the housing for the sensor we were talking about. 3D printers take spools of plastic filament and actually melt the filament down into a particular shape. Inside the Innovation Lab, we have this electronics studio. This allows us to create the actual sensor package embedded in that case that we just saw. The sensor package is the brain to any instrument and what allows things to talk to each other. For this sensor, we have lots of individual components that are all organized together on this board that we designed and developed, such as this laser. The laser measures the distance to anything that this drone is sitting above. The other components on here tell where the laser is and the angle in relation to the drone. All of these systems we've designed and put together on this board so that they can talk to each other. There's also an SD card on here so that it saves all the data that this is seeing as the drone is flying around. And this is just one of the problems that our researchers are trying to solve that we help with. Now, the goals of this design organized and created how we would actually form it. It needed to be light. It needed to be on something that would fly. So we were able to make it out of plastic, and that met the design criteria for the researchers. This doesn't need to be thrown to the bottom of the ocean and survive a year. There's other systems and other ways of making things that we would leverage for that. This box core is an example of a bottom deployed instrument that's going to scoop up lots of sand and pull it all the way back up for researchers to look at. There's other tools that sit behind me that allow us to design and develop systems like this to meet other needs for research applications in the ocean. Let's take a look at some of the other tools that we have in the Innovation Lab to meet any wild question we want to solve. One of the first pieces of equipment we'll take a look at is the milling machine. Milling machines allow us to take away material precisely on a certain path. So we're making bigger things smaller in the ways that we want. Here's an example of something we do in cutting out a 2-inch diameter pocket in this piece of plastic so we could embed in something or make a cap for any kind of structure. And this machine allows us to take computer-generated profiles, such as this circular pattern here, and actually cut it into any piece of material we have in there, whether it's plastic or metal. The next machine we'll look at is a CNC Mill. This machine is computer controlled as opposed to the last machine that we looked at. This allows us to rapidly do very complicated designs that we completely developed on a computer. We can do these same pieces time and time again because of how this machine is controlled. Another unique component in this machine is a probing system. Now this probing system tells us where in the world all of the pieces of metal in here actually are relative to the machine. Otherwise, the machine would just wander about not knowing where anything is. In any part that we want to make here, there's multiple different tools that are involved in drilling holes or cutting out pockets or finishing any kind of sealing surface. This machine can automatically change from one tool to the next without having any user input from me. So it's able to easily and smoothly move from one operation to the next by changing that tool. Other pieces of equipment that we have in the shop are pipe benders and pipe rollers that allow us to make cages or other systems to mount instruments to the bottom of the sea floor. This we use a lot in our welding shop here, where we create the structures and the frames to mount everything together for any kind of deployment. For the systems that we looked at out in the innovation lab, we first designed and developed a computer model of these systems. This is an example of the LiDAR drone sensor that we were looking at earlier. This computer-generated model has all of the 3D printed parts, as well as all the circuit board components, all mounted together. We then take these models and we communicate them to the printer, and this printer will then make whatever we've developed in our solid models. Thanks for spending some time here with us in the Innovation Lab. This is just a small taste of some of the things that we do here in the lab, as well as Hatfield broadly. I'd really like to encourage everyone to come down, take a visit, and come say hi, as the door is always open.